Welcome to the Planet of Maths channel. In today's episode, we will consider whether it is true that 1 is greater than 0.999 going to infinity. The answer to this question seems obvious. Surely 1 must be greater than this fraction. Everyone knows that 1 is more than 0.9. Everyone knows that 1 is more than 0.99. It will be no different with such a fraction. Everyone knows that 1 is greater than what's on this side. But if we add these 3 dots here, representing infinity, will this sign still be true here? Strange things happen in infinity, and you'll see what I mean shortly. 0.999 to infinity can be written in this form. It's a repeating decimal. Let's take a closer look at our number. I'll call it x. Now I'm going to multiply everything by 10. Multiplying x by 10 gives me 10x. And how much will this be equal to? To multiply this number by 10, just move the decimal point 1 place to the right. And we get 9 from it. After the comma, I have an infinite number of 9s. This 0 is irrelevant here. Now I will rewrite this line below. I won't keep rewriting this pointlessly. I transcribed it here for a reason. We can underline all of this and subtract from top to bottom. 10x's minus 1x gives us 9x's. And let's see what's happening on this side. From the end, as we go, all these 9s, they cancel out. From these 2 9s, there's nothing. Similarly, these 2 9s cancel out. From these 2 9s, when subtracted, it is also 0. So really, I only need to subtract here, 9 minus 0. And 9 minus 0 is of course 9, exactly 9. But now if I divide everything by 9, it turns out that x will be equal to 1. X equals 1, and this x is that fraction. So the conclusion is that 1 is the same as 0.9999. Here is the answer to our question. This one is equal to that fraction, which may seem slightly surprising. But as I said, weird things happen at infinity. This example is an illustration of converting a repeating decimal to a fraction. We need to do the same with this decimal. That repeating decimal, when written out, looks like this. Will we be able to do it like we did in the previous example? It will also work. We just need to assume again that x equals that decimal. And again, we will multiply by 10, because here in this decimal, there is only 1 digit repeating, so we will multiply by 10. Multiply by 10 since there is 1 0 in number 10, just like there is 1 digit repeating. We multiply by 10, so 10x equal, and here after multiplying by 10, we move the comma 1 place to the right again, and it comes out to this much. The 4's again go to infinity, and we copy this x down again. While copying, we ensure that the decimal point is above the decimal point, because then it will be easy to subtract. We underline and subtract. 10x minus x is 9x. Here we're starting from the end. These two 4's give 0. This 4 with this 4 subtracted also gives 0. So we are already at this point. 4 minus 0, that's 4. Here's a decimal point, and 20 minus 2 is 18. I get something like this, and I want to calculate x. So I divide everything by 9. To get out of this somehow, it would be good not to have decimal fractions here. So I will multiply the top and bottom by 10. Multiplying decimals by 10 means just moving the decimal point. Here we get 184, and below I multiply by 10, and it gives me 90. With such a fraction, we can still do something. We can reduce it by 2, so we get 92 at the top and 45 at the bottom. And we need to rewrite this as a mixed fraction. There are 2 wholes. 2 times 45 is 90. So I still need 2 to reach 92. So here we have 2 wholes and 2 45ths, and that's the same as our initial fraction. We converted a repeating decimal into a fraction. We need to do the same with a decimal fraction, which now has 2 repeating digits, like this fraction. Again, we call this fraction x. Only that now if we have 2 digits repeating, we will not multiply all this by 10, but we will multiply by 100, because there are 2 repeating digits here. And the number 100 has 2 zeros. We multiply by 100 and get 100 x's. Our decimal point now after multiplying by 100 moves 2 places to the right, so we get 35 wholes, and after the comma, it will alternate 35, 35, 35, and so on to infinity. We rewrite this x again. There's quite a bit of rewriting here, but that's how it has to be. We keep the comma right under the comma. Again, we underline and subtract. 100x minus 1x will be 99x. And now we go from the end again. All the 5's cancel out with the 5's. All the 3's cancel out with the 3's. So after the decimal point, there's nothing left. After the decimal point, it's 0, so we don't write the decimal point, and the whole will be 35 minus 0. That's 35. And now we just need to divide it by 99. And it turns out that x equals 35 over 99. Here we might still consider whether this can be simplified by something, but it won't be simplified by 5, nor by 7, nor by 9. So this is our final result. This repeating decimal is equal to such a fraction. And also a fraction, which has 3 digits in the repeating cycle, but I hope you know what to do with it. We call this decimal x. And now we multiply by as many zeros as there are repeating digits in our decimal. There are 3 digits in repeating cycle, so we multiply by 1000. Decimal point moves 3 places to the right to this place. After the comma, we have 825, 825 to infinity. Once again, x carry over, making sure the comma is under the comma. This is how it will look. Now we subtract from top to bottom. This time it comes out to 999 x's. Now we look what cancels out here for us. 5's, 2's, 8's, 5's, and 2's cancel out for us. But here it won't cancel out, so this time we'll have a comma. 8 minus 1 is 7. 5 minus 3 is 2. 2 carry over, 1 carry over, 3 carry over. Here comes a big number, so the calculations are going to be a bit more difficult, but everything works the same. We divide by 999. We don't want a decimal fraction on a fraction bar, so we multiply everything by 10. It looks something like this. Now we notice that we can reduce this fraction by 3 because the sum of the digits in the numerator is 4, 6, 8, 15 is divisible by 3, so the entire number is divisible by 3, and the bottom one is also divisible by 3. At the bottom it's easy, but at the top you have to do long division. And we change it into a mixed number. There are 3 wholes. The bottom doesn't change. 3 multiplied by 3,330 equals to 9990. So how much am I missing to reach that number? I'm missing 409 to reach 10,000. And I'm still missing 10 to reach that number, so together it is 419. 419 over 330. And this is the value of our repeating decimal. This time the calculations were more complicated, but sometimes in such situations, you also have to know how to cope. And that's all for this video. Thank you for watching, and I invite you to tune in for the next episodes on the Planet of Maths channel.